All right, back to these silly units. So here we go. We have meters divided by seconds. Meters divided by seconds, that's a distance over a time, so that's a speed. Miles per hour. Remember that P is the same thing as the slash, but we're in America. We love to just say per, so miles per hour, that's also a speed. Kilometers per hour. This is what you'd see in Mexico and other places around the world that is not the United States. Kilometers per hour, speed. Kilometers. Kilometers, it's meters, that's a distance. Hours, HR, hours, that's time. Kilometers per hour east. It gave me a direction, so that's probably going to be velocity. This one also has a direction, meters per second, so, and it's going north, that's a velocity. Miles per hour downhill. No, that's another direction, that's a velocity. Okay, miles, that's a distance. Day, how many days? Days are time. Meters per second, second. Second. Anytime you see two S's at the end of something, that's going to be acceleration. That's new for this week. The same way to write seconds per seconds is with this little superscript, little baby 2, so it's also an acceleration. Meters, oh my gosh, it keeps coming back, and it will for the rest of the year. It is a distance. Seconds, that's definitely time. Make sure that's in the right thing. Yep. All right, which of the following units is used to measure time? That's a distance. Meters, there we go. That's force, and we haven't talked about any of these. It's seconds. Okay. What is the standard unit for acceleration? We just talked about that. It's meters per second squared, or meters per second second. Select all that applies. Which of the following are examples of acceleration? Well, when you speed up, you slow down, or you change direction, you're accelerating. You can't be accelerating if you're stopped, so not stopped. What is the SI unit for acceleration? Didn't I just have this question? Oh my gosh, I did. It came back. It's meters per second second, or meters per second squared. What is the formula to calculate acceleration? It is final speed minus initial speed divided by time. This will be important for some of the problems that we're going to do. So final minus initial divided by time. Red arrow, orange arrow, yellow arrow, all of these are in order trying to describe each one of these arrows. So let me just go ahead and explain this one. We have time, we have distance. It's distance divided by time. Anytime you have a slope or a line on a line graph, it's this divided by this. So this one is distance divided by time. So this is showing me speed. So it looks like my speed is pretty consistent here. So constant speed, but slower. Okay, right here we have no speed. The distance stays exactly the same. So go to orange arrow. This, if we are not moving, the distance is the same, we're stopped. Yellow arrow, it's going up, but it's going up bigger than this one. It's increasing more drastically. It has a bigger slope. So yellow arrow indicates constant speed but faster. Constant speed but faster. Green arrow, we're now on a different type of graph, velocity time graphs. This is pretty much speed divided by time. Speed divided by time, meters per second, second. This line shows us acceleration. This line is acceleration. So looks like we're accelerating pretty consistently at the green arrow. So do we have a constant acceleration? There it is. We're accelerating, and at the blue arrow it flattens out. So velocity or speed is the same. We've gotten on the highway, we're now still going 60 miles per hour or 60 meters per second. It'd be pretty slow. So this one's gonna be a constant. Nope, I lied. Constant velocity, because velocity is the same. Velocity, same. Going down, that's deceleration or negative acceleration. Negative slope. All right, an object starts traveling at a speed of 10, then speeds up to 20 in 5 seconds. What's the acceleration? Well, it's final minus initial divided by time. So final is 20 minus 10 is going to be 10 divided by 5 is 2. Let's try another one. An object starts at 50, then slows down to up to 10 meters per second. So final is 10 minus 50. If I had $10 in my bank account, I spent 50, my bank account's now negative $40. So negative 40 divided by 2. Negative 40 divided by 2, it should be negative 20. All right, what is the velocity at 3 seconds? There's 3. Looks like the velocity is 30. For how many seconds does the object move with a constant velocity? Constant velocity. Velocity is increasing, velocity is increasing, velocity is increasing, velocity is increasing. Here, 1 second, 2 seconds, 3 seconds, we're staying at 30. So 2 seconds. Boop, boop. 2 seconds. What is the rate of acceleration from 0 to 2? Ooh, this is actually calculating slope, and this is a bonus question, so if you can remember this, whoop, whoop, power to you. It's an extra hard question that some kids may get and some kids may not get, but we do our rise, which is 20, divided by our run, which is 2. 20 divided by 2 is 10. You will see that in math this year if you haven't already. It's called rise over run, and you're just finding the slope, which is giving us the acceleration in this case. All right, that one's submitted. Let's go ahead and go to the writing section. All right, we have this graph. This graph is showing us acceleration due to gravity on various planets increasing mass. We have the moon, which isn't a planet, that's funny, Mars, Venus, Earth, and Jupiter. Looks like we have different accelerations and different masses. So here's our acceleration on the moon versus Earth versus Jupiter. That gives us the mass of each one in kilograms, which gives us some absolutely massive numbers. Whew. And acceleration due to gravity on each one of these. So how fast you'd accelerate if you were to, say, jump out of a spaceship on the moon, you'd fall pretty slow. But on Jupiter, you'd be flying. Okay, you'd be over twice what you'd be moving on Earth. Okay, so there's a direct relationship between mass and acceleration due to gravity. Direct relationship, that means the line is going up. There is a direct relationship here. It looks like we are going up, but is that between mass? Yep, and acceleration due to gravity? Yeah. So looks like that claim is right. So let's restate the claim. The claim states, I'm just going to copy this thing. Copy. I'm just going to paste it. I do think this is a direct relationship. It's going up. So I need to support or reject it, and I support this claim. Use appropriate numbers or graphs. Dear Lord, these are some big numbers, but hey, let's do them. So I just need to pick 2 things to compare. Let's just pick, say, the moon and then another one. Let's just where we start, and it really doesn't matter which one I compare because any one of these would show a direct relationship. So let's just do the smallest and the biggest. Okay, the moon's mass is, let's see if we can get it all in one picture. Moon's mass is 73,500. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 1, 0. 4, 8. 5, 7, 6 kilograms. And the acceleration on the moon is 1.6 meters per second, while on Jupiter the mass is, or well, I should say, well, Jupiter's mass is 900 000 000 000 000 107 709 726 720. So while Jupiter's mass is this many kilograms, its acceleration due to gravity, is 24.9 meters per second. And really, there should be no space there. All right, did I use numbers? Yes. And did I use units? Kilograms, meters per second, meters per second. I did. So, big numbers, but when we do this writing, all you have to do is just really compare two things to support or reject your hypothesis, claim, statement, whatever. You should have a password that's going to show up right here. You got to use that password to retake this exam. Best of luck on that. Good luck.